In this lesson, we're going to pull Kubernetes secrets from Vault into our Kubernetes cluster using the external secrets operator. This lesson is completely hands-on. I'm going to provide you with all of the project files you need to follow along with this lesson. We're going to start by setting up a Vault server locally, and the idea behind Vault is that it's a centralized management system for all of your sensitive data. This can vary from API keys, usernames, and passwords. You never want to store these in plain text inside of your Git repository in a bunch of YAML files. That would be very insecure. You want to store them inside of a system such as Vault, which will provide encryption at rest. All right. And all of that sensitive data that is stored securely inside of Vault, we need a way to access it inside of our Kubernetes cluster. And that is where the external secrets operator comes in. We're going to set that up in module 2. All right. Once the external secrets operator has configured that connection, what we can then do is deploy these special Kubernetes resources called external secrets. And what those will basically do is, from the sensitive data that is being managed inside of Vault, automatically generate Kubernetes secrets that we can deploy in our Kubernetes cluster. Pretty cool, right? That means you never again have to hard code secrets inside of your Git repository. Then in module 4, we're going to test those secrets that get automatically generated by loading them up into real applications and ensuring that everything works smoothly. This lesson is lots of fun. I'm excited to show you how to set up your own centralized secrets management system so that you can use it at work, and I'll see you in there. Welcome to Module 1. In this module, we're going to set up a HashiCorp Vault server locally on our machine, and then right away, we're going to set up inside of it a key value secret engine. What this allows you to do is store sensitive data, be it API keys, passwords, tokens, whatever it may be, in the form of key value pairs at different paths. So you could have, in this case, one API key stored at the path org/kv/dev within your engine, or you could have another API key stored at org/kv/prod. And the reason this is useful is you have to remember that Vault is a centralized management system for your sensitive data. And let's say you've got one Kubernetes cluster that's deployed in a dev environment, one Kubernetes cluster deployed in a prod environment. Each one would need to access the API key that corresponds to it and can therefore reference the one it needs at the appropriate path. So it's pretty cool that Vault allows us to categorize our sensitive data in this way. All of that is centralized inside of the Vault server, and we're going to have a look at it now.
All right, let's get this party started. Inside of your video description, I left you a link to the following repository right over here. This repo contains all of the project files that you need to follow along with this YouTube tutorial. And by the way, this tutorial is also available as a written article for those who prefer to read. Although first, I recommend watching the video. There are some prerequisites that you need to follow along with this tutorial. kubectl installed and configured via doc. You can also have it configured via Minikube, but highly recommend Docker Desktop just so that your environment is consistent with mine. And Helm, you should have that installed as well, as we'll need it to set up the external secrets operator. Don't have that set up, go to this link. All right. Anyways, let's go ahead and clone this repo inside a directory of your choice. Doesn't really matter, wherever you can easily access the project files. All right, once you clone them, go ahead and drag them to your favorite editor. I like VS Code. Let's go ahead and open this folder. All right, and I'm going to spin up a new terminal session. Zooming in for you. Okay, so all of the project files for this video have already been completed because I want to focus more on theory and understanding as opposed to me mindlessly coding along, right? So here I already have a Docker Compose environment set up for you where you can easily, seamlessly set up a Vault server locally on your machine. Typically in an enterprise environment, Vault would be installed in its own separate server, but for the sake of expediency, in this video, we're just going to run it in a Docker Compose environment. Same thing, doesn't really matter. So in order to set up this Vault server, we're just going to cd into the Vault folder and run Docker Compose up. All right, so from the Vault image version 1.19, that's going to spin up a container that runs the Vault application. We're running it in development mode with the token root, which we're going to use to log in. And that's pretty much it. We can access it on localhost 8200 on our local machine. And yeah, that's as simple as it gets. We have a Vault server running locally on our machine now. So now let's go ahead and say localhost 8200. The token is root, remember, ROOT, sign in, and here we are. So you might have two secret engines already set up. One is a per token private secret storage. One is a key value secret storage. If you have a key value secret storage, go to secret engines, go to the three dots over here, disable it. All right, because we're going to create a new one from scratch. So I'm going to say enable new engine. It's going to be a key value engine. The path is going to be kv/org. Okay, just for the sake of variety. All right, the maximum number of versions that we're going to have per key. So this key value secret engine allows versioning such that each key can store many values for different versions. Okay, so an API key could equal 123 for version 1, 456 for version 2, and we'll set a maximum number of versions for 3. Okay, enable engine. That's pretty much it. So now if we go back to secret engines, we have one secret engine, a key value, one that starts at this path, kv/org. So all key value pairs stored will have one common path where they can be accessed by our Kubernetes cluster. And from here, the paths will differ. All right, so we can have one secret or one piece of secret data that lives inside of the path dev. So kv/org/dev. And what that could be is an API key that equals 123. The value will be saved as a string. It works for me. And we simply add it. Now we can toggle this JSON button and view what we have as JSON. Simple as that. So we'll go ahead and save this. And you'll remember that this key value secret engine allows for versioning. So if in the future the API key value for the dev environment gets upgraded, but we still want reference to the previous version of the API key, we can just create a new version, this API key, and set it equal to 987. All right, save the following. We can show the difference and save. So we've got two versions. All right, the latest version storing the value 987. So now we have one secret stored at the following path. We can create another secret stored at the path prod. All right, and this will also have an API key value, in this case equaling 456. We can view it as JSON. All right, and save the value. And that's pretty much it. Now in my current work, we actually have many paths, one for staging, one for dev, one for prod, and each one actually has many, many more paths. So API keys or passwords for Elasticsearch are stored under one path. API keys for Grafana are stored under one path, so on and so forth. All right, but for the sake of simplicity, we're just going to have one piece of secret data per path. All right, just keeping things simple. And so finally, we have these two values, all right, stored at different paths in our key value secret engine in Vault. How is Kubernetes going to access these values and from them generate Kubernetes secrets? That's where we go into module 2.
All right, we interrupt this broadcast with a very important message. If you haven't subscribed already, come on, hit that subscribe button. You'd be doing me a favor. All right, see you in the lesson. In Module 2, we're going to set up the external secrets operator. So you'll remember that Vault is a single source of truth. It's a central secret storage for all of our sensitive data, and we need to access that data inside of Kubernetes, while the external secrets operator is what will act as an agent that will fetch and always synchronize the data from Vault into our cluster. What's pretty cool about this operator is that it allows for automatic rotation. So if somewhere in Kubernetes it's relying on a password from Vault in order to do stuff, if that password were to ever change, this operator can allow for automatic rotation, ensuring that the data we use here is always consistent with data stored here. All right, let's have a look at it now.
Welcome to Module 2. In order to configure the connection between Kubernetes and Vault, we need to use the external secrets operator. Okay, we're going to install the external secrets operator using Helm. I've already left you all the commands that you need to do so inside of your Git repository. All right, so let me just refresh it, make sure I've got the latest code that you're going to use. Now, what I'm going to do is just run all these commands all together. Depending on the terminal that you're using, you might need to run them separately. Windows users, I highly recommend you use git bash in order to run any of these commands. All right, so assuming you've got Helm already set up, go ahead and go to your terminal. Just paste them in. Obviously, it won't recognize these comments, but it's going to go ahead and run the commands that we need. Just like that, we've got the external secrets operator all set up. That's really it for module 2. So if you took my Kubernetes course, if you didn't, highly recommend you do. You can access it over here. You'll know that an operator is just a custom controller that extends the Kubernetes API. What's special about operators is that they let you look out for custom resources that natively wouldn't be discovered by Kubernetes. So very simple. Operator can look out for custom resources, and we're going to be deploying them in module 3.
All right, we've got the operator all set up. How are we going to actually configure the connection between Kubernetes and Vault? That's where the cluster SecretStore comes in. We're going to provide the operator with a server URL that it can use to find Vault, an authentication method, and it's just going to configure the connection from there. Once that connection has been configured, then what we can do is define external secret objects. These external secret objects will reference whatever values we need inside of Vault, and based on these values, automatically generate Kubernetes secrets that we can then use in our cluster. All right, inside of external secrets, there's also a refresh interval that we can specify, such that we can say every 5 minutes, pull that piece of data again, just in case that piece of data were to be updated. So that's ultimately how the external secrets operator allows automatic rotation for our data. All right, pretty cool. Let's have a look at it now.
All right, welcome to module 3. So I've already got all of the necessary configuration files that you need. So remember, we've got 2 CRDs, custom resource definitions, that the external secrets operator is specifically geared to discover. Okay, so the cluster secret store tells the operator where it can find a vault. In this case, it's inside of Docker at port 8200, all right, hosted in a Docker Compose environment. It tells it the path of the secret engine where our data is stored. Remember, the secret engine, we gave it a path of kv/org. Or sorry, this is looking for org/kv. So what I'm going to do is, instead of changing it here, I'm going to change it over here. All right, so make sure that you do the same thing, kv/org. All right, version v2 specifies the version of the secret engine that we're using. This is version v2, as you can see over here. Whatever version it says for you, feel free to adjust these accordingly, okay? But from what I know, version v2 allows for versioning. Remember how each key can have many values for different versions, so that's what this secret engine allows for. v1 of the key value secret engine doesn't allow for that. So really important that you specify the correct version. And this basically tells the cluster secret store how we need to authenticate with the Vault server. And it references a secret called Vault token that lives inside the namespace demo. And it says there's a key inside of that secret called token. Use the value of that key in order to connect to Vault and be authenticated. We don't actually have this secret deployed yet, although I left you a definition for it inside of the GitHub repo. So go ahead and copy these commands and run them inside of your terminal. All right, everything's already been set up for you. So ignoring these comments, it creates the namespace and it creates the Vault token. All right, so now what I can do is say OC get secret called Vault token. Maybe make sure you can see this. Inside of the namespace demo, and let's output the YAML. Sorry, why am I saying OC? So at work, we're used to using OpenShift, which is a platform as a service that wraps around Kubernetes, but it's pretty much just Kubernetes. I should have just said kubectl. Anyways, so here is the token that our cluster secret store is going to use to ultimately have the external secret operator connect to Vault and authenticate. So if we base 64 decode this, so we'll say echo, put the following command. What was the command? Base 64-D translates to root. Okay. So now that we've got all of that set up, what we can do is start up another terminal, keep the Docker Compose environment running because you want Vault to be accessible by the operator. And now we can deploy these in our Kubernetes cluster. So just go ahead and actually just cd into external secret. We'll just start by deploying the secret store, kubectl apply-f secretstore.yaml. And what this should allow is the external secrets operator to find our Vault instance. So this will automatically get discovered by our operator. And so how can we verify that that connection has been made? Very easily. Let's deploy these external secrets. All right, so what these external secrets do is, assuming that a connection has been made between the secret store and Vault, then we can rely on the secret store to provide us the API keys that we request. So this Vault backend is going to start at kv/org. And from there, we request going to the next path, dev, specifically grabbing the property API key. Okay. And from this property, a Kubernetes secret should be generated. So I'll say kubectl apply-f external secret dev. All right. So now I'm going to say kubectl get external secret -n demo. Make sure it was deployed. We see an external secret utilizing the Vault backend store in order to sync a Kubernetes secret. And indeed it did. Here we can see the external secret has a refresh interval of 1 minute. So if we end up deploying, or if we end up changing the value inside of Vault, this refresh interval will allow the operator to generate another secret that has the updated value. Okay, so now let's say kubectl get secret -n demo to see if a secret was indeed generated. And indeed it was. Isn't that amazing? You never have to store secrets inside of your repositories in YAML ever again. You can just use external secret that reference whatever values you need from Vault, which are stored securely there, and then secrets are automatically generated inside of your Kubernetes cluster. All right. This is what we call DevSecOps, when we're using DevOps to automate things, but from a security perspective. Well, just one component of DevSecOps. All right. So now let's say kubectl get secret dash, and well, let's get the secret dev API credentials dash n demo, and let's output the YAML dash o YAML. And here you can see how a secret has been created using the following value. 987, this is just a base 64 encoded version. So now if I say echo the following value. Oh, by the way, Windows users, you want to run this command, use git bash, all right? Base 64-D 987. Now, what if instead I actually want to access version 1 of this API key, which is actually 123? Then what I can do here is just specify a version of 1. All right, so redeploying this external secret. Okay, and now I'll say, let me clear the output. We'll rerun the command from earlier where we output the secret that gets generated. Notice how now the value is different. Let's go ahead and base 64 decode that. So let me copy it. Clear the output, echo, base 64 decode. Beautiful. All right. So this Kubernetes cluster is in the dev environment, which is why we deployed the external secret for dev, which will pull the value we need at the appropriate path. But let's just say we were now deploying things into our prod environment. So the external secret for the prod environment would just reference a different path. That's really it. Same API key, but on a different path. So here the value is 456. But if I say kubectl apply -f external secret prod.yaml, that should automatically generate a secret based on this value that we stored in Vault. So now let's say kubectl gets secret -n demo. Yep, that's where it should be deployed. Now we have prod API credentials secret. Let's make sure everything is good. kubectl get secret the following -n demo -o YAML. Output the YAML. Here is the value that it's using. And so now we'll say echo the following value, but base 64 decode it. Should be 456. Amazing. So we're pretty much done the demo. In module 4, we're pretty much just going to use the secrets that get generated into actual pods. All right, see you in there.
Module 4 is just the cherry on top. So we've got these Kubernetes secrets that were automatically generated. We're going to load them up into some pods and consume these secrets. That's pretty much it. I'll see you in there.
Welcome to module 4. This one is going to be very simple. We're just going to test our secret using a pod. All right, so we'll go ahead and deploy that same pod in the same namespace as where the secret is so that it can reference it and be able to use it. And the way the pod works is it's just going to use the API key inside of the secret to print stuff and then sleep. All right, fairly simple test. We don't really need to do it, but hey, let's have some fun. We earned it. We worked really hard. So kubectl apply -f pod.yaml. Pod gets created, and now I can verify the existence of this pod. So kubectl get pods -n demo. We have an API consumer. We can stream the logs, kubectl logs -f API consumer-n demo. Here it's using the API key 123. Hope you enjoyed this demo. If you did, feel free to hit that subscribe button. And if you want to support this channel, make sure to check out my Kubernetes training course. I'll see you inside.